Okay, this thing's still running. It's been a while. That's pretty good. Okay, let's start where we were before. We have to stream UTF-8, and now we need to figure out how to write a UTF-8 stream. And slightly more complicated. Okay, step one, just copy this right here. It's write UTF-8 and 32-bit value. Okay, value. Step one, of course, make sure the parent is not 0. There's no result. Okay, step one. If value, we have to make sure that the value is 1 byte or 2 bytes or 3 bytes. If value is less than 0x80, that means it's less than 1 byte, but the last bit, the first bit right here, like the 0 bit of this byte 1 is 0. That means less than 0 is, it means that the first bit is 0 and is less than 1 byte long, less than 127 in binary value. You can check individual bits because it's a 32-bit value. Actually, it's a 31-bit value, but it doesn't matter. Okay, so we have to make sure we got everything right here. Now, we take that bit, and then we have to divide into whatever we need. Because it's 1 bit, so we just write it. I think I have a write UTF-8 byte. I think I have the function. I've been writing it. Oh, I got it right here. Type file stream write byte. I just copied it, so it doesn't matter. Type file stream write byte, simple enough. Okay, parent. Okay, value. It writes 1 byte, I mean. Okay, and return. Okay, next. We do the same thing as we did here, but we have to make sure that the value is 2 bits and actually we don't even check it. We have to make sure that it has to be below a certain value, because depending on the size of the value, we modify it to make sure that it's the right, that we need 1 byte, 2 byte, 3 byte, or 4 bytes. If else. Do we need the else? No, we don't need it. If value is less than 0x800, okay, make sure that's this is not the values that are set for UTF-8, because it really depends right here. These are fixed values. You can't really modify them any way you want, so they're fixed. Okay, we need to know which byte. What are we writing down? Okay, so it's 0x. No, what? How do we divide the bits? Okay, this is how it's done up here. So we need to figure out exactly how we need to do it. So if it's 2 bytes, then we only take the last 6 bytes. So how do we remove the last 6 bytes? We have to calculate the endianness. So it's not the first. So it's not the if we're doing a 32-bit, so we have to take the first. The rest of it is 8 bytes, I think. That's the continuation byte. That's the continuation byte here. So we need to shift left by 6 bytes to get the first. So it's 1, 2, 3, 4. That's the endianness is messing me up. So we have to shift left by 6 bits in order to remove, to get the first. That's how we're counting that's counting bits. Okay. Anyway, the endianness is messing me up because in a 4-byte 32-bit word, which one is the first byte? Okay, step 1. So we take value, shift it left by 6. Okay, this gets us the second byte. Okay, starting from the left. The second byte starting from the left. So we need to make sure what we're doing. This gets the second byte, but we have to do something else to it. We have to end it to remove the first two bits. Or is it the first 2 bits or the first 3 bits? We have to remove the first 3 bits. I need to look this up here, because we don't want to forget everything here. Is it 110, 110, 0xFE? Oh, we take this, but we need to reverse it. What's the reverse of this? Oh, 0. Oh, there it is, right here. There it is. I think I get it, but it's really hard to make sense of it. Okay, we shift it left, and we do an OR operation, an AND operation, just to get the last 1, 2, 3, 4, 5 bits. Okay, is it 5 bits? Oh yes, that's right. It's 2 bytes, so it's 5 bits. So 1, 0 is an error. It's the continuation byte, so it's the last 5 bits. Okay. You do an OR operation by 0x 1f. Okay, that's the second part. But there's one more part that we need. Okay. There's one more part that we need. I have to figure this out. Before we can store it, we have to take this right here. That's the value that we need. Well, actually, that's the 1x bytes that we need. That's the 5 bits. But we have to set the first 2 to 1 1. So what is 1 1? Okay, 1 1 0 is 0x0. Okay, now we're getting it. We have to set the byte 0x0. Okay, so 0x0. Now C0 or we have the 0x0 or whatever this is right here. We do this operation, shift it by 6 to get the second byte. We have to do it one by one. We get the second byte, and we 6 by 6 to get the second. No, it's not the second byte. It's the last 8. It's the second 6 bits. The value after the first 6 bits. The value after, it's not the second byte at all. Oh, this is complicated. You shift to the left by 6 to remove the last 6 bits, and then whatever is left, we add. We remove the whatever's at the top here, and then OR it by adding C0 to add a 1 1 1 1 0 plus the last 5 bytes is the value that we want. Oh, this is complicated. Okay, is it value? Oh, ch1. Let's call it ch1. Unsigned char ch1. That's the first char. Okay, ch1. Now ch1 equals this right here. Okay, type file stream wide byte. ch1. Okay, so far so good. But now we need to do something slightly different. Oh, we're not done. We are not done. ch2. ch2. What do we do for the second byte? What do we do for the second byte? ch2 equals. Okay, this is just going to be just as complicated. Okay, ch2 is basically the same thing. First, we take the value. Okay, shift it left by, is it 6? Oh, wait, counter. 6. Yeah, shift it left by 6. Oh, it's not 6 because we have to do it for every byte, but we can't shift it by, because you already shifted by 6. So it has to be shifted by 0. Oh, so it has to be done for every single byte. That's why we can do it that way. Oh, that's why we can do it that way here. We cannot write the byte here. Okay, that's why you can do it that way. We need to do it for every single byte after the continuation byte. Okay. Long counter. Okay. What do we need? I'm not gonna write it here. ch1. We need a clever way to do this here. ch1 equal value. And no, not just value. We have to remove the first byte. Okay, value. Actually, it doesn't matter. It's what it is, and counter equals 0, because we don't need to write any continuation bytes. This is unnecessary, but I need everything to be symmetrical. this part right here, I'm sure it's right. That's the first continuation byte. But now we need to figure out what to do with the second one. But we're not going to write anything yet. So it's value STL. No, it's value STL 1, 2, 3, 4, 5. But they have to be done backwards, don't they? Ah, let's just do it right here. Okay. While counter is more than 0. Actually, more than 0. Okay. Counter minus minus. Okay, counter equals the value that we're shifting it by. Okay, ch2 equals, okay, 0x, okay, ch2 equals, so we have to take the continuation byte. What's the continuation byte? Okay, the continuation byte is 1 0. Okay, this is what we're using here, 1 0. We have to OR it by continuation byte, same thing we did by, in the other one. Okay, this is getting really complicated here. Okay, same thing we did here. Okay, so we copy this right here. Let's try to modify this. COX80. We have to take the continuation byte 1 0 and then OR it by the value, shift it right. Okay, shift it right by a value times 6. It depends on which bit are we taking by, because we have a whole set of six bits, a stream of 6 bits, like 5 of them, up to 5 of them, but it depends on the counter. Shift left by counter. 1 2 3 1 2 3 4 5 6. Okay, counter times, okay, counter times 6. We have to shift the left by a value equals the counter times 6. Okay, and okay, so that's the continuation byte. It's what is it? Oh, there it is, right here. Ah, we already have it. It's 3f. Continuation byte times 3f. Oh, there we go. Just move it in the other side. Okay, it's 3f. Okay, so OR to get the last 1 2 3 4 5 6 bits, and then we leave the first two blank, and now we take the entire value, shift it right to get this, to get the correct. There are 6 sets. No, there are up to 5 sets of 6 bits, and we have to find the right one from depending on the counter. Okay, depending on which one we get, we have to order the entire thing by this here 0x3f to get just the first 6 bit, the correct 6 bits that we want, and discard everything else. And we add the 1 0 here to the whole thing to make it a correct continuation byte. Okay, that's it. Oh, ch2, write it down, and we're done. That's for the continuation bytes. Well, counter more than 0, counter minus minus, and then ch2 equals this right here. We have to make correct continuation bytes according to this right here. All the continuation bytes between 1 0 and the last 6 bits are the values. So we have to find the correct value, or it by 0x3f to extract it. No, end it by 0x3f to extract the 6 bits that we want, and add 0x10, the 80, that's a 10, that's in binary, to make it a continuation byte. And we just do this backwards. No. Now we have to do this one byte at a time, but we have to go backwards based on the way that everything is stored inside the actual 32-bit value, because of little endian or big endian. I don't remember which one, but all the bits are stored backwards. The bytes are stored backwards for how they're stored in the bits. I have no idea why they do it that way, but that's just how they do it. Okay, so we have to write the first byte right here. Let's figure this out. Okay, you write the first byte, and then you write all the and you format and write all the continuation bytes. But now we need to figure out how to format each bit. Okay, the counter equals 0, ch1 just equals the value, but we need to remove a just to be symmetrical, and 1 0. We have to remove the 1 0. Is it 0 0 1 1 1 0? Oh, do we have one here? We need to have one here, I think. Shouldn't there one? 1. Oh, it's the 1 1 1. It should be here. This is not here, right here. Not here, not it, not. Oh, it doesn't exist. We need to calculate it. Okay, 0 1 1 1 1 1. Okay, so I'm gonna have to look it up. So which one is it? 0x. Let me just check it out. Oh, I got it. It's actually very simple here. It's 0x7f. 0x 7f. Oh, is it 8f or 7f? Yeah, it should be 7f. 1 2 3. How do we count the bits? Now whatever. Equals 1. No, it's 0 1 1 1 1 1 1 1. Okay, how is it 0 1 2 1 2 4? That's 7. Yeah, 1 plus 2 plus 4. Oh, that's 7. It is 7f. Okay, 0x 7f. Okay, this is completely unnecessary, but just to be symmetrical, let's just include it. Okay, that's 1. Counter equal 1. We're done. ch1 equal value, counter equal 1. We're done. Okay, ch1 equals, in here is c0. That's 1 1 0. And 0x1, that's the reverse of it. Okay, counter equal 2. No, counter equal 1. That's the number of continuation bytes. Okay, counter equal 1. Okay, that's 2 bytes. Now for 3. Oh, this is going to be complicated. Okay, 0x. Okay, so that's the values I'm getting from the documentation here. It's 1. It's how many zeros? Is it 2? 1, 2, 4 zeros. Oh, you have to make sure to get those numbers right because you're looking it up from the UTF8 documentation. This is not something you calculate. Oh, we need an else here. Otherwise, you're just going to get you're just going to jump in from one to the next, and it just doesn't work. Else 1 1 0. Okay, how do we do this one? Counter equals 2. Let's make sure we get this one right. Counter equals 2, but what are these numbers for here? Make sure you get them right. Okay, so it's 1 1 1 1 1 0, triple 1 and 0, triple 1 and 0. Okay, so which one is triple 1 and 0? I have to look it up from here. Oh, is that triple 1 and 0 is E0, and the reverse of it is we'll figure it out. Triple 1 and 0 is E0. Are we in the right place? Yeah. And the reverse of it is we need to check it out. I'm looking for it here. I don't think there's a reverse. I just calculate it manually. Okay, I got them all calculated, I think. Okay, so it's E0. Okay, for 2 bytes. Is it 3 bytes? No, it's 3 bytes. For E0, 1 1 1 0, that's 3 bytes. 2 bytes. Yeah, 2 bits equals 2 bytes. Well, that's how UTF8 works. It's well designed. Okay, so now we have 3 bytes, E0, and 3 bytes. That you need the first 4, and then the last 4 is 0f. Okay, so change this to 0f, and value is just 6. What do we need this for? Oh, okay, value is just 12. Okay, no. 6 times 2, 12. Okay, next. I think got this manually. Okay, we have to look up what the next one is. It's 2 0 and 1 2 4 zeros. It's 2 0. So we need to calculate this one here. It's 1 1 1 0. Okay, so that's what is that? That's F0, I think. Yeah, it's F0. And the last one is, we will move 1 0 here. So let's take the last 3 bits. So that's 7. That can't be right. Okay, so the last 3 bits, oh, we down here is 0 7. Yeah, we know what 7 is. Okay, try to remember how to do binary again. Okay, F0, that's, if you see 4 bits, it's F. If you see 3, it's 7. Okay, so it's F0, F0, and 18. Okay, 12 plus 6, 18. Okay, 0 7. Simple enough. Counter equals 3. So that's 4 bytes. Just make sure you get it right. 4 bytes. Okay. 4 bytes. No, what am I doing? Three bytes and 2 bytes. Not 4 bytes. 1 byte. One byte. Okay. So far, so good. Next. Okay, I got 4 bytes. Make sure everything's right. Yep, it's right, I think. Okay. 18. Can't equal 4. Okay, now let's 5 bytes. Okay, so we need to modify this one here. Add one more 0. That makes F. I think that's F. No, it's F8. F7 or F8? Yeah, it's F8. Oh, let's not mess this up. Okay, we'll move 1 byte here. That's 1 plus 2 equals, well, 3. Okay, but we need to go look this up here. Is it 4 zeros? Yeah, it's 1 2 3 4 5 zeros. No, 1 2 3 4 5 6 zeros here. Yeah, 1 2 3 4 5 6 zeros. Oh, do I get this right? We don't want to mess this up here. 1 2 3 4 zeros. 1 2 3 4 zeros. 5 6 5 zeros. I'm looking up the documentation and it's just not clear at all. 1 2 3 4 5 6. Okay, so it's 4 0. Okay, 1 2 3 4. Okay. I hope this is the right number because I cannot be sure at all. Okay, so it's F8. Make sure it's right. F8 24. 18 plus 6 24. And 0 3. Okay, I'm trying to do the calculation. Make sure you don't miss anything up. And counter equal 4. Okay. Okay, now for 6 bytes. Last one. 6 bytes. Okay, so we add one more number. It's 8 plus 4. I think that's 12. What's 12? F8 is FC. 12 is FC. Okay. 10 is A. 11 is B. 12 is C. Okay, it's FC. Okay, remove 1 here. It's 0 1. Okay, I think we got it. Okay, shift left 30. Okay, 24 plus 6, 30. So it's FC. Okay, the hard part is just really tedious manually doing everything here. FC, F0, make sure everything's right. Okay, I have to look up what this number is. I'm not quite sure what this number is. Oh, actually, it doesn't even show it. Oh, darn. Oh, there it is. I'm reading this here and really not clear what everything here means. UTF8 up to 6 bytes. Whatever. It doesn't matter. If it's not any of the others, then it must be this one. So it really doesn't matter. Okay. Okay, so is that right? SC01, 6 bytes. SC01, 6 byte. Character count is 5. And so far looking good. So far looking good. Okay, for the continuation bytes, we byte 1, ch2 counter, h0 parent. Okay, value. Okay, you don't want to get the spot wrong here, because if you get it wrong, it's just gonna read everything in the wrong way. Shift left by counter times 6 and 0x3f, which is this right here. That's the continuation bytes, and we're done, I think. Okay, return 1. Okay, I probably made a mistake somewhere, but just gonna assume it doesn't exist. Just to be clear, don't sign long. Just to be clear, don't want to mess this up. Unsigned long 80. Is that right? I think 80 800 1000. Oh, 200 400. That's why I get this. Okay, reading from here. U plus 4 zeros. Oh, just to make sure that we didn't get messed up here. 1 2 3 4 5 5 zeros. Okay. 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 I have to make sure that these numbers match those numbers here. 80 800 80 800. Okay. U plus 00 x7f. Okay. Yeah. 7f 1f fc. I think we got it. Yeah, I think we got it. You don't want to mess this up at all. Okay. So far, I think it's good. If there's a mistake, we'll correct it later. But mostly, this is good. Now, for the next slightly easier or slightly more difficult stuff, depending on how you look at it, file new, file, header file. Okay. Type, not type def, if and def. If and def, type file text. We have a stream file for reading individual characters. Now we need a text file. The reason we have to do this separately is because reading a text file is not as simple as it sounds. If you're just reading a data file, then it's very easy. But if you're reading a text file, then if you're parsing a text file with all sorts of different values, then it gets really difficult. For one simple reason. Because you have to check which character you're reading before you read it. That file text h and if okay, copy and paste. Okay, this is where it's going to get difficult here. Tag file text. Let me just copy some of the stuff here. Tab file text. Oh. Okay, tab file text. Open. Tab file text. Open new. Tab file text. Open existing. Tab file text. Type def. We haven't reached the hard part yet. Okay, tab file stream. Source. Okay. Now we get into the difficult part, the one that makes the text file necessary. In order to read from a text file, like take this text here, like the L right here. In order to know that it's a long, you have to reach the first character to make sure that it's a string and not a number. Like right here, I have a 0. It could be a number, could be a string, could be a quotation, could be a parenthesis, could be any number of things. But in order to know that, you have to read the first character. But if you read the first character, then you have to call a function. But the function doesn't know what character it's reading, because it doesn't have the L. Because now the stream is at the O. So when you call the function, the character that's reading is set to O. So you need a way to go backwards, but making the stream go backwards is possible, but it's not really elegant. I don't really like doing that. So we need a way to test the character, test which character we are reading, without actually we have to read it, but we have to test it. But the next character will know that we tested it, that which character we tested. So we have to find a place to put it. Unsigned long current character, not character. I just define that type character. Type def unsigned long type character. No, type char. What? Let's make it work. That way it just looks better. Okay, include type file stream .h. Okay. Now, wait a minute. Is it right? Type file stream. Just make sure we didn't mess anything up here. We get documentation. Make sure. Oh, stdio. Make sure that's right. Let's copy this part here, right here. Write UTF8. UTF8 just does its own thing, so it really doesn't matter that everything doesn't line up. Okay, write UTF8. Everything's good. Save, and we got it. Okay, save. Type file text .h. Okay, now we have a text file. Type file text. Open. If we have to make sure that we get this right here. If type file text, not type file stream, open new. If type file stream, open new, parent, not end parent, parent, file name, and not that. Open new, parent, not equals 0, and make sure we get everything right. Open new, return 1. We've said current source. Oh, parent.current source. What am I doing? Parent.current source. Not end parent.current source. Because that's the stream. And the file name. Current character equals 0. Actually, setting current character to 0 doesn't really do anything. It doesn't really matter. Don't bother with this. It just doesn't do anything because the character can be anything, including 0. Okay. Copy. Okay, if that file stream open character current, so now open existing current source. Now what else are we going to do? Existing, current source, type file text, open existing. Oh, copy this. Okay, to be clear, I'm going to save the neural network in a variation of JSON. The reason is I need to be able to read it, make sure everything's correct. Because if I just save it in a data file or a CSV file, I won't be able to read it. It's more complicated, but it's easier to deal with in the future. If I want to change something later, I can just change it. Okay, type file stream, type file text close. Type file text close. Is it close or destroy? No, just close. Okay, let's set to close or destroy. Oh, it's set to close. Okay, type file text, type file stream close. Binds the current source. And set everything else to 0. We don't need an if statement. Either works or it doesn't. Okay, return 1. Okay, now let's read something. Do we need a text character? We need to be able to read a character. Oh, that file's text read character. It's very different than reading a byte. Read character. Okay, unsigned. No, type char pointer result. Okay, if type file stream, just make sure it's the same thing. Parent. So do that. Type file stream read UTF8. Read UTF8. If that file stream read UTF8, whoa, did I have it here? Yeah, it's right there. So why is it complaining? That file stream read UTF8 parent.current source result. UTF8 result. Is it the same thing? No. It's probably the same thing, but just to be perfectly clear, value, not ch, and ch. It's probably exactly the same thing. Oh no, wait. Long ch, unsigned long ch. Okay. Result equals type char. It's probably exactly the same thing, but again, we need to be very clear on what means what. Ch, just in case. Okay, set return 0. Okay, now for the most important function. Peak character. This is the reason why we're doing this whole thing right here. Why we need a separate text file. Peak character is just check if the character is what it is. It just reads the character but doesn't move anything. Peak character. Okay, peak character doesn't need result. It's just reads the character if unless it's already read. If parent equals 0, actually it doesn't read the character at all. It's just if the current character equals 0. If current character, we didn't need ASCII, so current character equaling 0 means that that's why you have to check the if character equals current character is 0. If character not equals 0, in ASCII a 0 character is a null character, which means that the stream is over. If current character does not equal 0, what we do in stream right here, in stream a 0 character is perfectly valid. But in a text file, a 0 character means that the text is over, that everything's over. Oh, current character is equals 0. Ah, they have two different meanings here. In a stream, a 0 character is valid, but in a text stream, a 0 character means everything's over. Okay. Read character. Ah, okay. We have to set the character is. Okay. Okay, here. Result equals 0, but also current character equals 0. So if you need to read a byte, so you have to set to ch. On type char ch. Not type char pointer, type char ch. Okay, every time you read a byte, you have to set it to current character. Otherwise, everything breaks. Okay, so that's what we have. So when picking a text file, we read pick character to make sure that the current character is valid. And if it's a valid character, then then it's good, and we continue reading. Okay, if I set current character to 0, does that work? Ah, when we open the file, we have to read a character. But when you open the file, you have to make sure to remember to read a character instead of just picking for a character. That doesn't work. If you pick for a character before you read the first character, it will just fall apart. Ah, so we're done. Well, we're not done. There's a lot more to be done, but this is the basic one. Read a character, not parent. You read a character, and you check to see if the character is valid. Then you read the next. If the character is a string, a letter, then you can read a string. If it's a parenthesis, then you read what's inside the parenthesis. If it's a quote, read what's inside the quote, and so on. And so far, that's it. There's a lot more to be done, but this is the basic. To read a text file, and of course, read UTF8, which is the hard part. Well, it's the hard part, but the other time is the long part. Just have to hope that we didn't mess anything up. Okay, read character, peak character. Okay, that's it for today.